All right, I'm back again. Wow, I had a couple days of flu that was really hard on me. Uh, so anything feeling better than my worst at this point feels like wow, 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 wow. Pattern change here. We have really mild waves. So only enough force, mild waves with only enough force to put smaller rocks, basically pebble-sized rocks, and smaller, with a mix of sand grain size. That's coarse grain sand. And so it has enough force to wash that up. And then that force dissipates without enough force to backwash it. So it allows most of it to stay. There's always a little bit of backwashing, but the net gain is that it upwashes and not giving more to backwashing. So you'll have all kinds of stuff washing in and out, and you can read the forces, the distribution of the forces based on what moves compared to what stays. And somewhere in between that is your middle way, which is essentially where you make sense of what's going on. So the distribution here has changed, but anyway, it's changed over a couple days. But anyway, last time I talked about that pattern of rocks right there. You can see that segment being the functional middle way of this small bay area during big wave events. This is small, not even relatively small, but properly small for this area. And if you went through all my other videos, what I've posted 8 or 9, would this be number 9 or 10? I don't think this would be any more than 10. This would either be 10 or 9. But that means at least 6 videos of being here and getting to see the wave sizes. And this is the smallest that the waves have been in any of the videos. So you get to understand that this is really small, properly small for this area. But when the waves are really large, they wash up these larger rocks. And in the really, really big events, they can smash into the cliff face here and do the dislodging from the cliff. Those, and you can tell that those were dislodged from the cliff and fallen down towards the ocean. And they never made their way to the ocean because they still have their angular sides and angular corners. Whereas the ones that have come from the ocean have spent enough time in the ocean to get the rounding that the movement of the water does to them. So you can tell the rocks that have spent time in the ocean and then washed up. And you'll see some of them deposited, some ocean-worn rocks deposited even higher up than these that were knocked down from the cliffside. So stuff like that just washed up from the ocean. Waves hitting so hard. We're talking hurricane force waves. They happen. So you'll notice that even the stuff washing down from the cliff takes a position in the bay. It's not too much to that side, it's not too much to this side. It's as if it's roughly trying to fit in the middle, which is where the forces of the wave comes in, big wave comes in, a line, and the further it comes in, the more it compresses, because the shape of the bay compresses it, which concentrates the forces towards the middle, and they're the strongest at that point, which is where they wash down these big rocks. And then the big rocks wash down along that middle way path. And then where rocks are washing up from the ocean, the same thing is true. Except when you see the ones washing up from the ocean, the middle way is where you'll see the biggest ones, the biggest pile of rocks or line of rock pile. And you'll notice the rocks that wash up from the ocean, their middle way pile is a bit more offset than the middle way pile of the ones washing down. But if you look closely, you'll see that the smaller of the big pieces that came from up there off the cliff, that some of there's a line back there, I can see from here, there's a line back there that actually runs in line with this stuff coming from the ocean. So there's probably two different scale of events that made these two lines of deposits. But either way, coming down or washing up establishes that middle way. And this middle way isn't in the surface area middle. You have to think of it as a whole dynamic system, and then you'll understand why, even though that's offset from the surface area middle, which would probably be more like there, why it's pushed more that way. The whole system about the distribution of forces, it's not an individual parameter by itself. It's the mass, and it's its motion, and it's its way of distribution all together. And so the distribution is geometric, and the geometry is complex here. And that begins to define even the very quality of the middle. It doesn't take away the preeminence or the dominance of the middle way needing to establish itself. It just redefines it a bit, shifts its position. You have to shift your perspective to follow it, but it's still there. And so when you look at the system as a whole, you'll notice that this side is clear, and that side has all that rock mass, heavy, solid rock mass, even bigger and heavier than this stuff. That stuff is heavy. So it's a lot of mass with a lot of energy, with the ability to resist or redirect a lot of the wave energy, and redirect it in a way that breaks it up and redistributes it. Which means the forces on that side, before they even hit this line here, they've been reduced, redistributed, and sent in different ways. So even though the forces came evenly across the whole line here, by the time they reached there, that stuff, those big rocks, began to change the forces on that side and basically weaken them once they get into here. So the forces that compress against that side are weaker than the forces that compress against this side. This is open. The forces just free flow in, uninhibited or minimally inhibited. And on that side, very much inhibited. So the balance of the middle way would shift towards the weaker side. The stronger side would push against the weaker side. But that middle way line of forces still maintains itself, even though it's geometrically shifted. So the middle way by itself isn't about the two-dimensional geometric establishing of an axis, where you take a top and establish an axis and have it spin around, and then if you shift off of that axis, you've no longer got that axial stability, and so therefore, is it even an axis anymore? Same thing with the Earth on its axis, its middle way axis. You can have a middle way equator belt, look at it that way, or look at it in the other direction, north to south, a middle way axis running through the Earth, or a middle way equator belt around the Earth perspective. And would it be an axis anymore if it shifted off of the center balance of Earth rotation? Would it be an equator anymore if it shifted off the middle belt of the Earth? So here, when looking at the middle way dynamics, there's something more to it than just your two-dimensional establishment of balance. It's still an establishment of balance. It's still an establishment according to geometry, but it's much more dynamic. It's everything together: gravity, the mass, the motion, densities, shapes of individual rocks, shape of the space within which they move. All of those things combined together factor into where the middle way is established. So it's universal in that sense. No matter what parameter you're looking at, the middle way is a reading line, a navigation line through it all. You can read into every parameter through the middle way, or every parameter feeds into the middle way. So this is a small bay area and a very scattered mess, and still the middle way pattern. Look at the larger beach. So that's the larger beach. You can see the black sand. So that's a much larger area. Is that 100 yards across? That's probably more than 100 yards across. And it's a dynamic location. This beach is a dynamic location between the wider bay. So that point right there is to my left. I'm facing out to sea, and to my left, that point is one side of the bay, and you can see it arcing in the inside of the bay, arcing all the way across. And to my right, while I'm facing out at sea, to my right, that's the other end of the bay. So this becomes like a bowl, a dish. And the wave forces coming out from sea, once they cross this line from outer point on that side to outer point on this side, once they cross the line established by those 2 points, they begin to compress their forces into this bowl. And the forces begin to find their middle way. Remember talking about the middle way according to the distribution of forces that make that larger rock pile established there, and how you can have little things. Well, that's relatively big enough, still little on the larger scale, but big enough to sway things on the larger scale. So all kinds of things in the shaping of the bowl can sway how the compression of the forces between both sides take shape. And it is a geometric process, a geometric conforming. So you should be able to see geometries deposited. That line of rocks, that it takes a linear form. Now this is a scatter plot, and we talked about scatter plots and delineating your way through scatter plots, finding patterns that stay close to the physics of the matter, you know, not getting too daydreamy like we do with clouds, but it's similar to looking at the clouds and seeing what shapes you could make out, and not getting too daydreamy like we love to do with the clouds. I'm sure there's a good reason for that. But staying close, looking for shapes that stay close to the physics of the matter. And as scattered a mess as it looks like, you'll see the wantings for a straight line, and it's basically the middle way line and rocks trying to conform to a line. They're doing their best, but when none of the rocks in their own individual forms have the geometry suitable for being good conformists to linear geometry, they do their best. And it's pretty impressive for how scattered this is. And according to scatter plot logic, you just draw a line through it and see that everything's doing its best and coming closer to a straight line than otherwise, which is good enough for what would otherwise just be chaos. And you can navigate by it, and you can read into it the dynamics of the forces going on. And behind the forces of it all is very precise geometric distribution. And one of the evidence of it at the very basic level is the regularity that you can count in the wave motions, and then the ability to predict the wash up, how far to wash up. I think in the last video and predictions, I was able to put my finger at a point before the wave came and mark the point where the wave was going to be before the wave even arrived there, and have accuracy at that again and again and again, over and over again. Maybe not 100% accuracy, but enough accuracy to get a B+ or an A grade. And in some short periods of time, like if you watch me for 5 minutes, you might see me get 100% accuracy. And then over the course of 30 minutes or an hour, I might drop back down to 85% accuracy, 90% accuracy. And then on bad days, I don't even try. But once I get warmed up and I'm in form, accuracy is always very high. So that is predictability. And I understand by the heft of the water and its movement, and I'm used to the mass of the water, the sensing of its weight, its density, and all of that, by having been in the water and moved with it. So even outside of the water, I can just look at it and I know its dance, and so I can say that it's only going to go that far. And so today the waves are really, really small. There's not much action to work with. Anyway, so there's other forms of predictions that I'm able to do down here, and I'll try to talk about that on the wider beach down there. So I'll start again. So one prediction feat that I do is point on shore where the wash up of the wave is going to reach before it actually gets there, and have high accuracy at that. So there's a way of the water's movement, its mass, and everything that allows that to be possible. And there's even calculations that you can do. Mathematicians, physicists work with calculation processes like a formula that allows them to show that, yeah, there is something to it, and you can predict it. So let me go down to the beach and cover another form of prediction. Two more down there, two different kinds. So here down on the wider beach, you have the sand. Some scatterings of rocks, but mostly sand. And then as you get closer to the edge here, you start to see rock piling. And on the opposite side of the beach, I don't want to turn the camera towards the opposite side right now because there's people on the opposite side. I'll go to the opposite side and show the opposite side from the opposite side rather than cover the whole beach. But on this side, you have all of a sudden, all the way to the end, rocks piling up on this side. And on the opposite side, you have the same trend where rocks always want to pile up. And the way the rocks pile up here are different than on the other side. But the fact that they collect on either side, that side collecting on that side, this side collecting on this side, and then the middle being open, that's a middle way pattern. Rock collection on one side, rock collection on the other side, and then the middle being dominated by open sand. The two opposite sides dominated by rock collection. Now you'll see as you get down closer to the water, you'll see a difference in the scattering of rocks. Then at a certain point, you see a change. So I learned to read that line where the change happens. And you'll notice the waves today are averaging out along that line. So this one came across that line, but is close enough to that line to be part of averaging out to where that line is. And so the difference in rocks that you see there is about the wave pattern and its depositing of rocks. So when the wave pattern changes, you'll see changes in the pattern of rocks that it deposits. So there are times you'll come down here and the wave pattern changes that this entire heap of rocks is not here. And there will be other times when you come down here and this entire heap of rocks is actually made up more of rocks that are larger size. So these larger size rocks will come up in larger numbers. And bigger wave events do that. Bigger wave energy can move bigger rocks. Lower wave energy moves smaller rocks. So that's about the edge of the limit of the rock deposit on this side. And there is an edge limit. Oh, almost slipped. It's slippery here. There's an edge limit to the deposit. So it's a wide area of the beach that gets deposit. And actually today, the deposit field is much wider than usual, but it stays within a given area. The widest area that it'll expand into and the smallest area that it'll expand into. Never going beyond that. Maybe on rare occasions when hurricane forces, the very rare events, maybe unusual things can happen. The whole beach can get redefined. Big trees get wiped out. So now I'm able to look at the other side. Now you can see the other side of the beach where the sand stops. And if you look closely, you'll see a rock pile on the other side. Those are old trees that got washed out by hurricane force waves. And you'll see rock deposits on that side. I'll go over to that side and look at the rock deposits there. So rock deposits on that side, right there. Sometimes you'll have the rock deposits up against this wall. There are still some, but they're buried in sand right now. We've had a wave pattern that's actually bringing sand up. And you have the rock deposits there, and sometimes they'll be here, and that's for that side of the beach. Just like the other side of the beach has its own rock deposits up against that edge. Now, on that side, I was able to read the rock deposits at the very edge of the water. There was a day where there was a man caught in a wave and it was tumbling him like in a washing machine. And he was caught in the cycle to where he couldn't get out of it. So I went there and I knew I couldn't just jump in and pull him out because then I'd be in the cycle with him. And he was out of control and had enough of his own body mass to probably overwhelm me and keep me in the cycle too. So I just stood there and watched and waited, but not just watching him, watching the whole system and its movements and looking at the rocks where the water was meeting the shore. And I noticed the pattern of rocks there different from the rocks higher up. And there was one particular rock of a large size that I hadn't seen there in the previous week. I would go every day and see the rocks there. And this one rock was of an unusually larger size than all the rest. And there it was. So I knew over the previous 2 days wave pattern that rock had been put there. And so the trend in the wave pattern at that time was to move rocks of that size to that position. And that position where it was relative to the waves coming up and then the deflection of the waves off of that side there, the waves hit that side and they deflect. So how far over this way that the rock was relative to the deflection off of that wall, and how far up it was relative to the forces of the wave bringing it up. So I knew that guy, with just reading his relative body mass, that guy would end up eventually at one point in the wave cycling him, drift to where that rock was. So I stood there where that rock was and waited. And before he could drown, he drifted over to me. I said, "Give me your hand." He put his hand up amid tumbling and being out of control, put his hand up, and I grabbed it and I said, "I won't let go." And I pulled him out. He was heavy and smelled like cheeseburger. So it was not easy. And he had tumbled around so much that he had nothing left. And he made it. He laid there where I was able to drag him out, and laid there until he got his energy back and then got up. But I was right there at the safest point for reaching for his hand and pulling him out by reading the rocks and predicting where things in the water would be moving based on where the rocks had been moved by the water in the past, the recent past, relative to that point in time. That was years ago. So that's another prediction based on reading the rock movements, their positioning. So the rock pattern on this side, up close, I was able to do a different kind of prediction here. Now, the prediction I did here, I'm trying not to get anybody in the video. All right, there's people on the beach. I'm not trying to film anybody. I'm trying to film rocks, water, and sand. There was a problem here. It was a ever-growing trend, a new trend. After coming here every day for 10 years and seeing the pattern of how things were normally, and this tree never having a problem of being excavated at the roots, and then being gone for 10 years, and then coming back, and over the course of the last 4 years, about 4 years ago, seeing the trend persisting that this tree was being excavated at the roots consistently, and the trend was not going back and forth with, favoring that it gets covered up and then maybe another time. It just was consistently excavating and excavating, and the only reprieve it got was resting at a particular extent of excavation, just resting at that extent of excavation, but not reversing the excavation. So it's back and forth, the ocean back and forth. And so you'd expect that back and forth pattern to happen all the way up here, but something was going on with the trend, causing it not to happen here. The trend was shifted to just a one-sided excavation, not filling in, just excavation. So that's not balanced. That's not the middle way. So somewhere there was some kind of imbalance, maybe disruption. But you can see what the first measures were. We would see it happen and pile rocks into the roots, so that when water comes, it just hits the rocks and washes back, rather than hits what the roots are rooted into and excavates more. So the rocks we were stacking as a shield against further excavation of the trees. And these are ironwoods. You lose the ironwoods and you don't get them back in your lifetime. These grew before anybody's lifetime here on the beach, and we're benefiting from something before our lifetime. And so to get the benefit of them again will be well after our lifetime, if the beach is even here. This is a volcano. The volcano can decide no more beach. There was a much better beach here down the way, Kalapana Beach. Much better beach, famous beach. And it's gone. The volcano decided. So ultimately it's the volcano that decides. So the initial measure was just shoring up the tree roots with rocks. And that was just too tedious because you have to keep up with it. So the waves come, crash against the rocks, and minimal impact on the tree roots rooted into the ground. But then the rocks do their job, and some of the rocks get taken out by the waves. So you got to come back and rebuild, and a vicious cycle of doing that. Now that's good exercise. So my mentality was, that's my workout routine. And it's not every day that the waves are so powerful that they're, taking rocks away. So you do hard work until you're worn out, and you get a rest period. And by the time you start getting fat and lazy, then big waves come again and mess up all your work, and you have to get back to work and the good exercise. So what I did was just looked at this whole area and the dynamics of distribution of forces. And if there was a pattern, and a middle way pattern emerged, and it showed itself in the rock distribution on the ground here. Now, right now, we have a wave pattern over the past week or so that has deposited sand to bury everything. And so there is a trend that's building up sand over the past 2 weeks. But underneath this all is a rock scattering. It extends out, just like on the other side of the beach, how the rock scattering extends out. So there's rock scattering buried underneath, but there's a pattern in the rock scattering, and there's a position right about here where there was a linear rock pile that always maintained itself. Sometimes it would be smaller, sometimes it would be larger. And I realized that was the middle way line for a distribution of forces. And the proximity and the linear alignment relative to where these trees were getting excavated was no coincidence. And so this line was where deposits wanted to collect. But something about its form had shifted the balance to make the trend want to excavate. So I figure that's a natural part of the system that we can't do away with. You can't just take it all out. The distribution of forces over the wider scale of the beach will just come back and meet there and create more deposits. So maybe it needed a helping hand of adding more deposits on top of what was naturally deposit. So look at the deposit as it was naturally made, and then add to it a little extra. So I added to it a little extra and watched it and saw how deposits grew upon what I put. So I would make an input, and a natural input would grow around it. I'd make another input, and a natural input would grow around it. And I would do this off and on and watch it. And sometimes my work would be washed away, and I would watch how it would get washed away and reconstruct around that and see the limits of where I could extend the deposits. The deposits don't want to deposit outside of the range of the distribution of the forces. Anything outside of that, and nature will correct you. So you have to build within the parameters that nature establishes, basically conforming to nature and then supporting it. So if you're going to do your own man-made influence, it can't be by your own design. It's got to be by what nature is designing here. And all you do is you build a support on top of what it's already doing. Not your own remedy, but its own natural process, and then supporting it. And so eventually, over the course of 6 months, and the bigger picture was at least a year, maybe a year and a half. But the first 6 months was the real learning period, and then I just got confident and stopped studying and just stacking rocks based on my intuitive following of it. And one day I decided that, okay, I think I've put enough rocks here, and a ton or a few tons of rocks position, and now the chain reaction for many, many more tons of material to grow around that. And so for it to have an impact that far up, we would need a big wave event that can impact that far up. And so there was a big wave event that totally reconfigured the beach. But it did that according to the trend of building up deposits. And that was maybe 2 years ago, maybe a year, more than a year. And ever since, one of the things it did was it buried my work. Not washed it away, buried it. The work was about causing deposits to grow on it and around it. And deposits grew on and around it so well that it literally buried my work and continued the trend of building up and building up. And now the tree, the root exposure problem is gone. Not entirely, but if you saw the problem before, it was serious. This, not so bad at all. And the problem was also here. And the problem here is also gone, at the very least, brought to a minimum. And doing work here by the prediction that the geometric configuration and mass positioning of rocks here, that it would cause the trend to change, predicting by that. And it worked, a successful prediction. Now, something like this isn't something I could do 2, 3, 4 times over just to establish that it's a prediction. This time I did it once, it worked, and that's it. I'm not going to go dig it all up and start again just to prove that it's a predictable, it was a prediction, that I can do it again and again. No, it worked. We got what we needed out of it, and it's good to go. This is a natural beach. You don't mess with the environment just because you want to prove something. I messed with it just because I wanted to improve something that was out of balance. And what is it about that area where I made corrections? What is it about that area that causes rocks to want to deposit? Just like, what is it about this area that causes rocks to want to deposit? And then on the opposite side of the beach, what is it about that area that causes rocks to want to deposit there and not in the middle? And this area of imbalance, there is an area where rocks deposit in a line. So just like it was over there in that other small bay, more chaotic from the previous videos, there are wave forces coming from this side. There's wave forces coming from that side. And where they meet to cancel out and drop the rocks that they're carrying is relatively somewhere. It's all buried now, so I can't be exactly sure, but I know I'm relatively in the right spot. So the two waves meet and create a middle way where rocks drop in between the two. Two waves meet, cancel out their forces, and then the forces don't just disappear, they backwash. But where they met and canceled out, just in an instant, all the rocks dropped. And the backwash was not strong enough to wash all the rocks back with it, so they deposited it. And that wave pattern repeats again and again, one after the other, and grows and grows. And something at some point caused it to still be there, but in a way of not tipping over the edge of where would it be the trend of continuous buildup versus the trend of washing away. Something was not, it was stuck somewhere that wasn't good for deposits further up the beach. And so the trend was just excavating and probably losing the trees. So I played around with it to find and found something and built upon it, and then changed the trend. So the middle way pattern was what was going on there, and I built upon it in a way, slowly, studied little by little, put a piece and study how it holds or how it washes away, and then go another piece. And then once I decided I understood it well enough, then I just started piling rocks where I knew they should be, until I had enough in place to trust that the chain reaction that would grow from there would just carry on its own over the long term. And it's been over a year, and it has. And two waves meeting, making deposits, and deciding that I need to leverage that for a trend of making deposits uphill, a prediction. Now, reading the deposits and making predictions for the trends. So there is a large scale distribution of forces, and large scale meaning from that end of the bay to that end of the bay, way out there. So that large scale line of water coming in brings forces in, and they compress, and there's push that brings rocks this way, and on the opposite side of the beach there's push that brings rocks in that way. And then the center is the most free and open to where things wash up, and it's just as free and open for things to wash back. So rocks wash up and back in the middle, whereas on the edges here, things washing up with powerful forces which are so broken up by all this big stuff on the side that the backwash forces aren't strong enough to wash things back. And so it's the same thing on the opposite side of the beach. So that's on the edges. But at key positions along the beach area, in between the rock deposits on both sides of the beach, in between that, there are key areas of rock deposits. And rock deposits that aren't as widespread as on this side or the other side, but the size of rocks match any of the rocks here or exceed the size of any of the rocks here. So powerful forces at those positions. Let me see if I can go to one now. So this is the area where using rock pattern distribution to read the trend and help come up with something to change the trend and make the excavation of the tree roots reverse. Now, why do we have this rock deposit here? Why do we have... It's just a small area of serious rock deposit. What happens here that causes the rocks to all get collected here? You'll see it trails off, and then it clears out. It clears out before the normal edge line rock deposit happens. That's mirrored on the other side. And then cleared out. And then all of a sudden, serious rock deposit starts happening here. What's going on here? So everything's a geometric distribution. Is there a middle way dynamics going on here? How do you uncover a middle way delineation? I don't see a line. It's more like just a rounded heap. But this was an area where I used to sit every day. This was my high ground. In those days, this tree was not fallen. This tree was still standing, and its shade was here. There was a hurricane that passed by, and the serious waves knocked the tree out. And it washed out all the high ground that I had, but still kept this area as a serious rock deposit. And there's something about the distribution of forces that creates a deposit here. So there's a meeting of forces coming from this side, and this side, and then slapping together and canceling out. And when I used to use this area as high ground, I used to build a platform to shore it up, and instead of being jagged like this, I'd build rockwork platform and fill it in with gravel and then sand that I'd bring up little by little. Did that for years, and then I'd work for a month and have it good for another 2-3 months. Then a big wave event would come and mess it up, and then I'd start work again and rebuild. And I got to study how the waves worked, how the rock shifted according to the waves and all of that. And one day I noticed that from my spot here, looking at that edge of the bay, a straight line, and then the other edge of the bay there, a straight line, the two straight lines. So that straight line there, let's adjust. There's people there, so I'm not going to film, but I'm not going to film that direction. But what I was doing was out there, roughly there, the umbrella lined up. That's the edge of the bay on that side. There's the other edge of the bay there. I'm not going to film it because there's people there swimming. I don't want to get people in the video. So what I did was I turned away from the camera. I kept the camera facing that way, away from people, and then I turned towards the people and kicked this umbrella into alignment. And there you have a 90-degree angle. Now, why a 90-degree angle? And I first took this reading or measurement years ago from my position up here. And so I haven't brought a square to determine that this is an exact 90-degree angle, but I'm experienced enough to know that's as close to a 90-degree angle as you need to be out here in what is relatively, or actually, not just relatively, but actually a scattering of delineation. So your lines will be scatter plot lines. And the fact that we have a 90-degree angle relationship between the two outermost edges of the bay, and that peculiar rock deposit there that stays, and it may break apart, but it redeposits. And that one in particular, you never get to see it deposited. You come back after the big wave events that are so big, you can't be down here at the beach. We're talking the hurricane force events that wiped out trees like this. Old ironwood trees. Wiped them out. So you come back to see the carnage the next day. So that peculiar rock deposit there gets shifted around by the biggest wave events only the biggest wave events, the hurricane force events. In all my 10 years of using that daily as a high ground and building a platform there, comfortable and everything, and studying the water and rock movements from there, I never saw the forces that it would take to make the original rock deposits that were there, which I then built upon to make safe high ground for beach users, myself included. After a hurricane event, then I saw the changes to that location. Old stuff moved around and new stuff brought up. And then I realized that deposit comes from the largest events of all, which are very rare. You can wait 20, 30, 40 years to see those events come about. And I waited, it was 2016, between 2001 and 2016, had never seen the forces come about. 15 years. And then after 2016, Hurricane Iselle passed by, knocked down all kinds of trees, or literally excavated them up by the roots, wasted them away, reconfigured, renovated the whole scene of the beach, and then that peculiar rock pile was also renovated. So then I understood what I was dealing with. But on the smaller scale events, while I was using that rock pile as my high ground, I noticed that I was building along the natural deposit lines, because anything I built outside of the naturally occurring rock deposit lines would easily just get washed away. And so there was something about the wave washing pattern that decided where rocks could be and rocks couldn't be. No matter, I would bring the biggest rocks I could to resist the forces, and they just wouldn't resist the forces. They would wash away. And so something about the way the distribution of forces happen. It decides where things can be and cannot be. And sure enough, that's where you find things naturally being or naturally not being. And so I built upon where things naturally are, and then take only from places where things usually are not naturally occurring. So there's a place where rocks usually are not occurring, typically on the beach ground, flat and open, where people come in and out of the water. If rocks show up there, not always there, but when they do show up there, they become a hazard. So I would take rocks out from there to be out of the way of people, and then use that in building up high ground on shore, which would then be high ground for people to rest on when they're out of the water. So find that middle balance of where to take from and where to put. And if I took rocks from the water and put them somewhere up top where the natural distribution doesn't allow them, they just get washed away and I wasted my time. So learning the natural system. Now, I noticed over the years of doing that there were certain big wave events, not the biggest wave events, but significantly big enough to where I'd be on the high ground platform and it would barely be safe up there. And every once in a while, a wave would come and splash over the entire platform. But it would hit from both sides of the platform I built, and the two waves would meet each other right over the edge of the platform. I built the edge of the platform on that side. I built the edge of the platform right at a natural line that I found there, a natural line of rocks that I found there. I knew if I built across that line, the forces would wash it away. So I stayed right on that line because that line was depositing. And I saw that day the big waves come and splash over my construct and meet and cancel out right on that line. And that's when I first understood that the two waves come and cancel and they drop the line of rocks where they met. So the linear formation of the rocks is actually the linear shape of the wavefront. The wavefront comes as a line. And I measured a 90-degree relationship at that rock pile. A 90-degree relationship between that end of the bay entrance, or that end of the bay opening, and the other end of the bay opening, which is really wide, relatively wide to my size. Swimming that distance would be triathlete feat, I think. Maybe not, but way out of my league. It's a long distance to swim. So a 90-degree relationship between that rock pile that's created only by the largest wave events. And the largest wave event would be a line of water from that side all the way to the other side, coming in, and then both sides of it wrapping around and splashing together at that point and dropping the rocks. And that's why the rocks there are so huge, because the largest waves, only the largest waves do that around here, and they can carry the largest rocks. And they splash together and cancel out and deposit. And each successive wave splashing together and canceling out just reinforces it, compresses it further together into a tighter compact, and deposits more when it can. So why the 90-degree relationship? Why the 90-degree relationship? I never understood that. 90 degrees seems a little too clean and a little too much like human architecture. What could it be? That location is defined by the middle way, the two waves the two sides of the wave wrapping around in the bay and coming together, splashing together, canceling out right there. And the middle way between the splash up is where the rocks deposited. So that location is a middle way for the waves coming in and bringing the forces. So how is 90 degrees a part of the middle way? And then it struck me that 90 degrees would be half of the linear, how should I say this? The wave comes in as a line. So what's the degrees, the angular degrees for a line? A line is 180 degrees. If you cut a line through it at the middle, you've created two 90-degree angles. 90 and 90 is 180. So you split the line down the middle with a line, and you've created 90 degrees and 90 degrees. And so the middle way of the line, and this line of wave from across the opening of the bay, the wave comes in as a line, and then it wraps around itself and splashes together up against the cliff wall there and deposits its contents at a location that draws a line out that way to meet that point, draws a line out that way to meet that point of the bay opening, and it makes a 90 degrees, which is half of 180 degrees, which is the line of the wave out there once it enters the bay. The line would be 180 degrees. The 90-degree relationship would be split the 180 degrees in two, and you have 90 degrees and 90 degrees. So the middle way is showing split in half. I'm still kind of trying to figure out the three-dimensional way in which that might come together. Looking at it, a line and 90 degrees, that's a two-dimensional reasoning, but all of this is happening in three-dimensional form. So there could be a bit more dynamics going on, but still we've captured the signature of the middle way in that. So once again, we failed to escape the middle way. Well, I wasn't trying to escape the middle way. I already know where I stand with the middle way. I can try to escape. I can try to not escape. Either way, even the process of trying to escape versus not escaping is going to be a middle way predicament. Now, the other thing is I went to the other side of the beach, which I can't film right now. And the other side of the beach and a rock deposit on the far other side of the beach. And significantly sized. And I went to the edge of that rock deposit closest to this direction. And also did that linear marking, and it too is showing very good conforming to the 90-degree angle relationship. That side of the bay and this side of the bay, which is out of view. So two areas of the beach where that 90-degree signature shows. So could that be the balance? Meaning one area with the 90-degree angle and the other area with the 90-degree angle adding up to account for the original 180-degree angle, which was a line of wave, accounting for that. geometric redistribution of the forces, as well as the geometry of the mass carrying the forces. Isn't that interesting? And so we are dealing with a waveform establishing these patterns. And this is part of the geometry of music and logic. So if we go back to music, we did the numerical chart, the geometric circle chart, showing the relationships between notes and stuff and how we make chords and scales, and there's a harmonic pattern. And it looks very much mathematical. And it is, but all conforming around a middle way. I want to say a middle way logic, but there's something more to it. Logic itself is probably arising out of the middle way. That before logic, before math, before physics, before any of that, the middle way was. So my hesitation to characterize it, to find a word for it, or even if I am giving it, it's giving it words and definition, I'm still hesitant to feel that I know what I'm doing, or hesitant to believe that I'm actually capturing it for what it is. So the best I feel I can do is just show where it's demonstrating itself. Now, when we go back to music, the charts that I did, those were geometry, math, a statistical survey, you could say. But it didn't get down into the nitty-gritty of the physics. Physics would say, well, this is based on sound. When you're looking at those charts, numerical model, the geometric model, you don't hear anything. You're just seeing numbers and shapes. Whereas music, everybody knows music to be a sound. If you just show people a bunch of pictures, a bunch of handwritten, hand-graphed models that are just pictures, after you invited them to some music, they'll be like, we don't hear anything. And because they don't hear anything, they'll say, where's the music? Even though there you have it in front of them, the models for what music is, the numerical model, the geometric model. But you're seeing something that actually occurs as sound. And all you're showing is the patterns that happen in the unseen world of sound. You're bringing a visual model to represent the geometry of what's going on in the unseen world of sound. So now physics would say, let's go into the unseen world of sound itself and come up with the shapings going on there. And so you can zoom in on a musical string, pluck a musical string, and there you have your sound. And then zoom in very close to the string and watch its vibration, and you'll see waveform dynamics at various speeds, various shapings of the waveform, depending on the tone, the pitch, the various parameters of the sound that you're playing with. And so waveform dynamics are what's playing out there. And here, waveform dynamics, and it's establishing lines and other geometric signatures. Talked about the 180-degree line, and then seeing the 90-degree relationship from deposits on the beach to the two different ends of the bay opening, and that a doubling of the 90 degree would be the 180 degree line, and making a half of the 180 degree line would be 90 degrees, and two sets of 90 degrees. And so you have two sides of the line, and that's the making of a middle way. So paying homage to the middle way still. So what we find in music, you saw how everything there in the geometry of music was paying homage to the middle way. But there was something else that I didn't cover. I was working with one octave. When you play music, you have multiple octaves, and each octave is just a repeat of the previous octave. So on the piano, I like a full-size piano, which is 7 octaves, which means your 12 chromatic notes is 1 octave. Then progressing forward with another octave on top of that, and another octave on top of that for a stream of notes, 12 notes, 12 notes, 12 notes, 12 notes, 7 times over. And you've got a full-length piano. Except when you play all 88 notes, one after the other in fluid stream, it doesn't sound like 7 different octaves. It sounds like one fluid stream progressively going up in pitch, or if you play it from top to bottom, progressively going down in pitch. So you play it like that, and it sounds like one fluid stream, just a fluid spectrum. And essentially, that's how nature is. Except when you look at the geometric patterning of that progression, you'll find that from note 1 to note 12, you never repeat a note. By the time you get to the 13th note, it's a match of the first note. And then by the time you get to the 26th note, it's a match of the 13th and the first. And so after every 12th note, you begin a repeat of the same note progression pattern. So from C all the way up to B, all 12 notes. And then the next 12 notes again will be C all the way up to B. And then the next 12 notes, C all the way up to B. But when you're playing all 88 notes in consecutive order, fluid succession, it doesn't sound like it's broken up into sets of 12s. It just sounds like one fluid stream. And essentially it is, but there's something happening in the spectrum where after a certain point, you're just repeating the same notes except in a higher pitch. So the lower C is the same C as the next C up. And that C is the same C as the next C up from it, except it's going to have a higher pitch. So you can substitute them and they will work harmonically, but then the parameter of their pitch will be different. There's going to be something higher about one and something lower about one, but if you play them together, they'll sound like the same. There won't be any disharmony. There won't be any sense of even that there is a harmony. It will sound like one note. You could play 4 different octaves, the same note from 4 different octaves, play all 4 notes together. The C note from one octave, the C note from the next octave, and the C note from the next 2 octaves over, and play all 4 of those notes together. And it'll sound like one note. You won't hear the crunchy harmonies of, say, your typical triad chord. And you won't hear disharmonies of having played something that's a contrast to your standard middle way harmonies. So why is it that we have that repeating of notes at every set of 12? That by the time you complete a set of 12, you just repeat the notes of that set of 12 in the next set of 12, and do that over and over again 7 times on a piano. And it can go on and on. You can have more than 7 octaves if you really want to, but it becomes hard to hear for the human ear where the enjoyment of music is concerned. So what's happening? So you take a closer look at the waveform dynamics, and they were able to give a numerical rating of the waveform. So you have things like 440, 220. So you'll look at the number rating given to the waveform for a particular note. You hit that note, that's 440. So what is that, hertz? Anyway, you can look that up and get into it. But what you'll find is middle way dynamics down at the physics of it, that every octave up, you'll find that number for the rating of the waveform has doubled. So the C at this octave, if it's 220, the next octave up, the number for that is going to be 440, a doubling. And then up from that is going to be what? 880, a doubling. I'll have to check. I don't know if it's 220 to 440 and then 440 to 660 and 660 to 880, or is it an actual doubling, 220 to 440 to 880 to 1760 and on and on. Anyway, I think it's the doubling. That's what I learned. The doubling. So, isn't that interesting? So out here in these waveform dynamics, we see things playing out where the doubling of the 90-degree angle phenomena, the relationship between the 2 ends of the bay and the rock deposit on shore, creating a 90-degree angle, and how the 90-degree angle doubled is creating the 180-degree angle, which is the line of the wave coming in to create all of that. That's a harmonic function, because in music, the doubling is a harmonic function. Maybe in this case, if you look from the source coming inwards, then it's a halving. If you look from where the 90-degree angle is established and looking outward, then it's a doubling, depending on which side you look at it from. So are you cutting something in half, or are you doubling it? If you look from the original piece that was cut in half, then you're halving it. If you already have the 2 halves and you look from there, then you're doubling them. So what are the chances that you have that doubling? If you're at the high end of the piano going octaves down, you'll be cutting in half at each octave. If you're starting from the bottom going up, you'll be doubling. And seeing those dynamics playing out here. And so having cutting in half and doubling is the very basis of the middle way. This half, and then the middle way. This side, and then the middle way. Or just one of everything, and then the middle way through it all for the benefit of contrast or equating. So that's mathematical and physics. And so still the middle way through and through. I'm not escaping it. And just getting deeper into it and coming up with useful predictions that helped me save a guy's life. He was going to drown, and it was a situation where I couldn't go in there with him and pull him out. I'd just end up with him in there. So looking and reading the patterns according to the middle way dynamics functioning down there, and using what I saw to predict where that system, according to the middle way, reading the system for where, according to the middle way, it would trend towards drifting him. And that's where I would wait, rather than going in to get him, wait for him to come to me. But I would need to be where the water was going to bring him. How would I know where the water's going to bring him? Water's just a chaotic, flowing mess. You can't predict where it's going to be, what it's going to do. Well, the middle way will show you something different. And I've shown where it demonstrates itself amid all of this that looks so chaotic and unpredictable. There are little clues here and there, and the right universal things are inescapable. Even in the most chaotic systems, they're inescapable. And the middle way is one of those things. I'm still daring to say that it's a universal thing, which means if we go out there on the solar system scale, we should see it. If we go out there on the galactic scale, we should see it. I really don't care to look any further than the global scale, global tectonics and stuff like that, the whole Earth. Not that I'm going to look away from galaxy. I'll look at the pictures of the galaxy. I'll learn about galaxies, no problem, but not putting my focus and deep interest or my foremost focus towards that. I have a focus and an intended goal that has to do with understanding a global complex system related to global tectonics where earthquakes are concerned, and predictability amid the chaos. I had it working for me down here, just based on a few clues here and there, and had it working out for me. And then suddenly found myself with the ability to read ground motions and sort of see a pattern in global earthquake distribution patterns. Everything just seemed to have a strange familiarity to me. Like, man, I know that from somewhere. I couldn't quite exactly pinpoint how it related to everything going on down here as I'd come to understand it, to whatever extent of understanding I do have about things down here. I couldn't quite explain it, but I was like, man, it sure does seem a lot like what I'm doing down here. And I had grown so used to doing it down here intuitively. Just intuitively, I would forget about thinking about it and just flow with it like I'm dancing and involved, taken up in a music. But because I would do music analytically also, I would take some time to wonder about things down here analytically also. But spent a whole lot of time just caught up in it, intuitively feeling, going with the flow of it, like a dance, just enjoying the water and its movement, but having ingrained in me a sense of its patterns and able to make predictions about where to put rocks, where not to put rocks. Look at where rocks are and understand how they might have got there and what forces were involved, and therefore if there were people in the water relative to where that rock was, I could predict where the water was most likely to bring them, just by looking at the rocks that the water had brought about. And because I had picked up a whole lot of rocks, I could understand what size of rock it would take to match my body weight. I picked up rocks as big as my body could handle, rocks that would overwhelm my body weight. So I would know that water that would be able to move a rock like that into that position had the forces to move something else into that position if it had a certain range of mass. So I would say, well, that rock looks like it would take enough water forces that would be needed to move a human person, move their body into that position. If it could move that rock, a rock of that size and weight, could definitely move a person. And so if a person was out there, that's where the water would move them. And sure enough, I found that to be true. And it didn't happen just that way alone. It didn't prove itself to me that way alone. I would be out in the water and find the water drifting me around. And I would find myself being drifted into a rock on the ground under the water. And I would touch it, I would feel it, I'd say, oh, I don't want to get hurt by that. And then I'd move away from it to escape it. And then slowly, the water's movements would just slowly drift me back into it. I'm like, wait, I just stepped away from that. What am I doing back here? So I'd get away from it. And then I realized the water had a trend of drifting me in that direction. And I had that happen so many times over the years that it struck me one day, it's not just me being drifted into the rock. It's me being drifted to that position by the water. And that the rock being there is because it too was just like me in being a body in the water, and the water was drifting it to that position. So it wasn't about me, it wasn't about the rock. Me and the rock were just the same subject to the water and its forces of its mass and motion. And that became a clarifying thing. And then adding to that, where after picking up rocks, so sometimes I step on a rock in the water, and I'm like, you know what? The water's just going to keep drifting me back to it. So let me pick that rock up out of the water and bring it up on shore and use it to build up a high ground, or stuff it in and around the tree roots where the ocean water seems to want to erode the tree away. These trees taking hundreds of years to grow. Long before I was born, it'd be sad to see them gone. So I would do that and learn the weight of the rocks. I would know that the water had the forces to put that rock there. I'd pick up the rock and understand its weight by feel. And then also see the water having the force to push me to where the rock was. And then I'd understand my weight and the rock's weight, and know somewhere in between was the middle way of what the water was able to do. And so if someone was out there in distress, in a situation where going in to get them would only put me in the same peril that they are, my second option would be know where to wait in a safer position where they would come to me. So I had that work for me. I had that work out for me where I was able to save a guy's life. Nobody was willing to go out there and get him. It was that dire of a situation. He was caught in the washing machine cycle. That's a terrible thing. And even though I went out to get him, it still didn't mean that I went in to get him. No, I found an alternative way, which was predicting where he would be based on what the water was doing and where the water had previously deposited rock. So using past events and present situation to predict the future of which at the time was where he was going to be, and thus that's where I would go wait for him. And he ended up there just before his last breath. I said, "Give me your hand," and he stuck it up, and I grabbed it, and I didn't let go and pulled him out. So useful predictions. How much more useful can a prediction be than to help your life carry on in the face of things that want to end your life? That's what survival's about. And it's not just here in the water. People die here drowning, so it's not just here with the water. It's all kinds of situations in life. Predictability. So earthquakes, tsunamis, volcanic eruptions, those are killers too. And predictability, finding useful predictability. Don't expect 100% predictability. Don't expect that every aspect of it can be predictable, but latching on to the right things that give useful predictions, and the most useful one being allowing the circumstances of avoiding being caught up in the deadly onslaught of what earthquakes and tsunamis can bring. And so since you can't stop them, since you can't deflect them, they're just too big and powerful, knowing ahead of time when they're coming, knowing ahead of time where they'll be coming from, and then adjusting yourself, your position, your activities, and all of that. And even if that's the best we can do, if it makes the difference between people dying because of earthquakes and people, rather than people living despite having earthquakes coming to ravage their homes and towns, that's the difference between life and death. And if what you gain out of useful predictability is life, then it's very, very useful and well worth it.